So, what happens in classification and regression problem? So, here what happens? So, now let us study deep learning. So, deep learning, as I have already told you, it's a combination of several neural networks. So, the basic architecture of your neural network is going to be based on basic structure of your deep learning models will be based on neural network. In that, what you have this three types of deep learning models we usually come across. One is called as artificial neural network, and another one is called as RNN, another one is CNN. So one is ANN, RNN and CNN. So what is this ANN, RNN and CNN? So ANN means artificial neural network. Ignoil, you can hear me, right? Okay, you can see the screen also. Okay. So now we have artificial neural networks, recurrent neural network, and see this based on this. What is a neural network? How our nervous system is going to work? Based on that, the same architecture, these neural networks are designed. From one nerve to another nerve, neurons are interconnected with the nerves. So nervous system is there. The nerves are going to pass the information. So from one neuron to another neuron. Same here, instead of neuron we call it as a node. The same concept how our nervous system is going to work. In the same way, this neural network is going to work. So the architecture is same. So before understanding, going deep into this, we have to understand several things. Yeah. So we have to study the basic. So for example, if you see here, so I have already told you. So I will write like this. So let us say you have. So this is. So I am writing like this. So these are called nodes. So I am passing the input. What is this? I am passing the input x1, x2, x3. So from here it will go here. So from here it will go here. From here all possible combinations. It will go here. From here it is going to go here. From here it is going to go here. So from here it is going to go here. So from here again here. From here. So what is this? So this is input and this is the output, and these are called as whatever the intermediate layers. So from these are called as what? Nodes. What is this? Nodes. These are called as nodes, and this is the output. So this is this layer, what I call it as input layer. What is this? Input layer. So and this, what I call it as hidden layers. What is this? Hidden layers, and this is the output. So each node, if the information from one node to another node needs to be passed, means what is that? We have to pass on. If we want to pass on the information from one node to another node, so each node needs to get activated. Okay. So without activation of any node, nothing is going to work. So how to activate? We have several activation functions. So how each node gets activated? So there is a mechanism for that. That I am going to tell you. Not now. Next class I will tell you, because another students are also there. So I will come back to you that activate. So we have to activate. So you just keep it in your mind. So now you see here. So we have to update. Say x1. So this is node number 1, 2. Let us say 3. So W12. What is this? 2. So this W1 and W23, something like this. W3 23 W3 2 1 2 3. So something like this, W3 2 W3 1. So you again from second node to third node, W2 to 3, second node to third, this is first node, okay, so W, whatever you give, what I can make, okay, W3, I will write like this. Simply I have given nomenclature. So what is this? So here, what is the input? X1 into W12. So what is this? What are the, so let us say, so this is W23. So for W23, what are all the inputs? For W23, what are all the inputs? Okay. So for W23, what are the inputs? Here?
X3.
1 minute. This X3. You are saying something, Shobha? Yes. So look here.
X.
See W23. So this is the case. So this one, right? So 1 minute. I will draw. So you will understand. See W23. I want for W23. So this is W23. So for W23, what is the output coming out? This is what? This is output. Output coming, this is the input. So what are the inputs? So X1, so this from here it is coming, right? From here it is coming. From here it is coming. What are the inputs? So I will say that W X1 W12 plus what is this? X2
X2. W.
W21.
1.
You
X3.
X3.
W32.
Yes, very good. W32, not 32, 31. See this one.
31.
31.
Yes,
W,
yes.
W3. Means this output this is going to be summation of all the inputs. That will be the out. So this is, or let us say the output coming out of this node is Y. Output coming out of this is Y. Getting from Shekhar what I am telling? Yes. So means Y is equal to summation of means X1 W1, X2 W2, X3 W3. Or in general I can write it as summation of I is equal to 1 to N Xi Wi. This is the case for each and every node in the neural network. This is the case for each and every, means you have to consider several, and so from one side to another side, so from here to here, so from input node to the output node. If you go from input node to the output node, we call it as forward propagation. What we call it as forward propagation. So forward propagation. So similarly, so this is not just a open loop system, this is a closed loop system wherein there is a scope for optimizing the results. There is a scope for checking the results and checking this with what is this Y? What is this Y? Y is the output. What is this Y? Y is the model output. Just like your machine learning model, this is a deep learning model, that's all. This is the Y I can say is Y bar or Y cap, something like this. So what is this? Output. So already you have the actual output is Y. This is actual and Y bar is model output. Yes, or predicted model output. So now what happens? What is the loss function? Just like in machine learning, how you are finding, here also you have to find out the loss or you have to find out the error. Simple in machine learning, how you are going to do? So the loss function. So loss function, sometimes they will call this as cost function, sometimes they will call it as error, everything is same. So Y minus Y, right. What is this? Y minus
Actual
actual minus predicted.
model.
Predicted or the actual minus the model output. So here what happens? So now I need to do in deep learning lot of theory is that right theory. You just because it is very important to understand the theory. Okay. So now let us see. Now what I can say is, let us say if you want to get a good result, so if you want to get a good result, so if you plot the graph, uh, what is that we are going to plot? Loss. If you want to plot the loss versus weights, okay. So as you are going to update the weights, okay, my so let us look at this figure. This is what? This is the point I want to reach. Okay, what is this? This is you already know this. I have already told you several times. We always want to reach global minimum. So now this is what your global minima is when error is, so the distance between the actual and the real model is only this much. Actual means y minus y hat, the distance is less means only that much is the loss. Okay, that is close. That is so. But so okay, you deploy some deep learning, and you are here, and you want to reach here. So for this, if you want to reach here, so you want to reach to this global minima. So what you have to do to reach, okay, global minima, what I have to do to reach the global minima, that is y should be almost close to y hat. If this y is almost close to y hat, so we will get the optimized model. So in order to reach that, what I have to do? I have to update weights. How the weights are updated? Weights are updated by methodology called weights are updated by methodology called as differentiation. Any doubts? Chain rule. What is this? Differentiation chain. So till now any doubts? Any doubts? Sunil, till now any doubts? Shobha and Ignoel, any doubts you have till now?
No, sir.
So the
No,
concepts
sir.
are clear, right? Sunil, you are getting right?
Yes, sir.
What about Ignoel? Ignoel, are you there?
Yes, sir.
You are getting right?
Yes, sir.
You are understanding?
Yes, sir.
Okay, good. So now what I am going to do, so look at this. This x1 into, so look at this model, x1 into w12, x1 into w12 input, x1 x2 into w22, so w22 that is w21 and w31 and w21. So look at this, all these weights needs to be updated. All these weights needs to be updated. How we are going to update the weights? Means weights are very small value that we are going to multiply with. It's a coefficient. Y is equal to mx. What is m? Slope is always constant. It's a ratio. So if the slope is too much, means what? What is happening? Means it should not be. So we have to update. Slope cannot be vary too much. So there has to be some. Similarly, W12, if you want to update the weights, means you cannot update from 1 to 1000, 1000 to 10,000, something like that. minor changes only. So how you are going to update the weights? If you update the weights, then what happens? This model output, whatever it is there, this starts moving towards here, where this one, this starts moving towards global minimum. This starts moving towards global minimum. So when this starts moving towards global minima, actually whatever the value of y, that is the output you are going to find. So that will be nearer to the exact value. So that is what we want to do now. Means if I have told you for only one node, see this output node also there is a lot of, to take for y, that is also y output coming. So for that also same way we have to take and we have to consider. Equation becomes bigger. Okay. So now what I have to do is, so now if you want to update the weights, okay, if you want to update the weights, I have one concept called as epoch. What is this? How the weights are updated? By differentiation chain rule. So you have one terminology called as epoch. What is epoch? So one forward propagation, one backward propagation. Complete cycle means you determined y, you took several inputs x1, x2, x3. You have the model determined the value of the output. After determining the value of the output, it checked with the actual output. It identified the loss. To minimize the loss, update the weight in one update the first for one node. For one node, we updated the weight. It will go back. It will update the weights, and after updating the weights, again the same input, it will calculate with that weight. That is one cycle. That is once means it will go back. We update the weights. So for example, earlier W1 was 0.1. Now the new weight of W1 after updation is, let us assume, 0.11. Now x1 y1, earlier it was x1 into 0.1, now it is x1 into 0.11. That one cycle, full cycle, forward propagation and backward propagation together, whole cycle, we call it as one epoch. So we call that as one epoch. So we need to update all the weights. So now what I have to do is, so in order to update all these weights, we have several algorithms, means not algorithms, optimizers. What you have? Optimizers. So what are these optimizers? So now you see for optimizers, for what these optimizers are? Optimizers are used for updating the weights, or they are used for modifying the neural network. See, it depends whether you want to see, several hidden layers will be there between input and output layer, n number of hidden layers. More number of hidden layers, more number of nodes, more number of time taken for training the model, more number of time taken for updating the weights of each nodes. So it depends. There are different ways of tuning this deep learning model. Either you can delete some hidden layers itself. You don't want unwanted things. You have 10 t-shirts. You have a lot of cloths. You give 2 cloths to somebody, nothing is going to happen. That is not going to make you poor. You have only 2 cloths, and if you give 1 t-shirt to your friend, you are left with only one. Then you are affected. Same way here also, deep learning model, several hidden layers are there. Sometimes we cut short and we will pruning the branches. We are going to cut certain things which are not needed. That is not going to affect the model. So that is one method. That is also going to increase your result. That is also going to reduce the error of the deep learning model. Similarly, updation of weights also going to help you. There are several ways, techniques. So updation of weights is one such technique to optimize the neural network. So now before going to optimize this, because already the Shobha and Sunil knows, just I want to tell you, I just want to show you also. If you see the neural network model, so how it is going to be, just see. See the images. See, look at this. This is how your neural network will be. Your input layers, output layers, and this is going to be, see, deep learning neural network. Deep neural network will be something like this. Several nodes will be there. Several hidden layers will be there. Okay. So several nodes, several hidden layers. Hidden layer number 1, 2, 3. You cannot do anything. You cannot find anything. In machine learning, manually everything you are finding out. You are checking each data, cleaning the data, pre-processing the data, doing lot of things, working on so many things, transforming the data, selecting the required. You have nothing to do. Everything system your network will do. You don't know how you are going to feel. You are telling so many things to her, to him. You are not understanding me, means what I can do. Why you are not understanding, I don't know. Because that is what neural network deep learning is. Because so many things will be going on inside you. You have your own perception. I have my own perception. Your age, your experience, your environment is different. My environment, my experience, everything is different. My way of expectations are different. So I am way neural, because you cannot identify. You just live, because that is how the things are designed. So look at this. This is what I told. Look at this. What is this? X1 W1, X2 W2, X3 W3, X4 Wn. So output. Before this output, what happens? This summation of this output, I just, what is that? I have taken the summation of all the inputs, and why I told you, this is going to be passed through the activation function. There are several types of activation functions. After coming out of that activation function, you will not directly get y. I told you directly you will get y. That y, whatever I wrote, that is coming out of the activation function. Okay, that is coming out of the activation function. So what are the different types of activation functions in deep learning? There are several that I have completed for them. So for you, I will tell you on tomorrow. As of now, you just keep one thing in your mind. Activation functions are the SigMoid. SigMoid is a logistic regression. It's an activation function. It will give you output. Classification 1, 0. Here also, SigMoid is also one of the activation function in deep learning. Like that, several activation functions are there. Okay. So now, what is my interest? So I want to learn about, we want to discuss about optimizers. So we have several types of optimizers. We have gradient descent optimizer. What is this? Gradient descent.
Delta.
Can you see? Yes. Who is that? What, Shobha?
No, sir. Optimizers types.
Optimizer types. You have gradient descent optimizer. You have stochastic gradient descent. Stochastic gradient descent. You have batch gradient descent. What is this? Batch gradient descent. Then ADA grad, ADA delta,
Sir.
ADA delta,
Adam something.
RMS prop, ADA grad, ADA delta, RMS prop, most widely used ADAM. Okay. So all these are the optimizers. This is what you need to understand in deep learning. Okay. You understand this, so then things will become easy. Okay, so now let us understand one by one. Okay, so you have gradient descent. So what do you mean by gradients? What do you mean by gradients?
Differentiate with weight means
Differentiate with?
loss function with
differentiate the loss function with respect to
weight.
weights. Correct now. So what is this formula? So looks like you already know some theory. Very good.
Same like the linear regression.
Same like the linear regression. So W volt is equal to what is this? How we are going to update the weights? W nu minus n neta is a constant into W nu or W volt. So I'm sorry. This is W means the new weights. I have to update the weights. The new weight is equal to old weight minus neta into loss function with respect to weight. So this weight is a recent weight. What I can say is the old weight. Okay. So now you see, this is how the weights are updated. So you have a neural network. You have W. This is the node. So this is output. So this is x1. This is x2. Okay. So this is W1. This is W2. So this is W1. Let us say this is the W1 you need to update. Okay. So W nu is equal to, I can write like this. W1 is the old weight minus neta into dou L by dou W1. Means what is loss? What is loss? W1 minus neta into what is loss? Y minus y hat. Y minus y hat. Dou of y minus y hat by W. I told you it's going to be happening with the help of differentiation chain rule. So if you want to dig deep inside the mathematics, I can teach you, but I don't want. Okay. So if you want extra class, you come on Sunday. How this mathematics? I have taught. That is not a problem for me. But you just keep this in your mind and go and see. That is for your extra. That is for your information. How no one is going to ask you, tell me the differentiation. Even he cannot. Can he derive differentiation chain rule? He will derive. I will give. What is that? No, it's not possible. Okay, so it's not difficult. Means you cannot remember. It's not like that. I'm not degrading anybody. It's not normally. So W nu is going to be updated like this. So loss function. See, we defined loss y minus y hat. So differentiation of y minus hat with respect to what is this? W1. You differentiate the same loss. Error you differentiate with respect to the older weights. When you differentiate the error means why I am differentiating to how much extent it is varying with respect to my earlier weights. That is what I am differentiating. So now after solving this equation, I will get the value for the new weights. After solving this equation, I will get the value for the new weights. So here what happens in case of your gradient descent? Gradient descent. The thing is that the first one is gradient descent, right? So what is this? So all data sets, the whole data set. See, suppose you have 10K. Data set is 10,000 rows, columns, some number of columns. So whole data set is considered once. It occupies huge RAM. You need huge RAM memory, huge RAM memory for this. And whenever it is everything you are dumping at a time. So what happens? It takes what is that? It takes more time for processing. Means it will reach global minima. To reach the global minima, you are dumping a whole data set all together at once. You need to update the weights of the whole data sets at once. So it will reach to global minima. It is not that it is not going to reach the global minima. It will take its own time. Slowly it will reach. I don't have time until you reach global minima. But you can use gradient design. It is not that you should not use. It is one of the optimization. It is also one of the. It started from here only. Everywhere you start from scratch. Then you go. You speak to a person who is fresher. His views and thinking is. You go and speak to a person 1 year experienced. You go and speak to what Arti? You got up now. Hello Arti, are you there? Okay.
Yes, sir.
Hey, you should join from 7:50. Anyhow, I'm recording. I'll send you. I'm not going to record from tomorrow. Please join. Okay. I don't have my laptop is full. Yeah, it's already hanging. I can't keep a lot of data here. Okay. Okay. So, what I was saying, yeah, you go and speak to a person who is college student. His views are different. His experience is different. Go and speak to a guy who has newly joined a company. His thinking is different. Go and speak to a fellow who is 10 years experience. Means what is the meaning? That means we are dynamic. Our thoughts based on our experience and our expertise and our age and whatever it is. Things change. Dynamic. Your views change. Earlier you are something your thinking might change. On the same topic your things will change. Mind is like that, it is going to fluctuate. So same way here also data sets are, if you take all together once, it's okay, you can reach global minima, it's not that, but just like assume that he is a fellow who has joined to the company new. That is what gradient is. He will learn so slowly. You need to pamper him. Or else you need to pamper him because it is not that not only you, everybody. Even what is that Narayan Murthy when he joined, he also don't know anything. You will start from scratch. No one is born with PhD degree. Correct? So same way, that is why it is slow. It takes a slow process. Everything, if you dump everything at once, it has to take all the inputs. Slowly it will converge. Slowly it will converge to global minimum. That should not happen. Optimizers means error y minus y hat, actual minus real. So what you want to do? You want to jump. You want to directly reach here. That is also dangerous. Okay, your leg might get fractured, or something can happen. You should not be too quick. You should not directly jump and take the decision. Okay. So what you have to do? So let us say now what I will do, instead of gradient descent, what is this? In gradient descent, what happens? All data set taken together. So all data set all weights has to be updated together. So it takes time. It consumes huge memory. Since it consumes huge memory, the processing of reaching global minima, the process is slower. So now what I have to do, instead of that, people came out with, stochastic gradient descent. What is this? stochastic gradient descent. So in stochastic gradient descent, what happens? In stochastic gradient descent, so here stochastic gradient descent. So here instead of taking all data set, I told you 10k data sets are there, 10k data sets taken together. But here in case of your stochastic gradient descent, I will take single value, single entries or single entities taken and gets updated. Single entities are taken and gets. When single entities are taken and when it gets updated, fast, but it is going to be a process is going to be quickly. It is going to update the weights quickly. It is going to converge to global minima. So means okay, one single everything. See, this is global minima. You are coming from here to here. This is your model is. This is the actual model. What is this actual? This is y. What is this global minima? Y hat. So this is also all points are y hat. This is also y hat. This is also y hat. Means, but y hat is the distance from y hat to y is high. I want to reduce the distance from y hat to y. So you have to reach. So if it is coming like this, it's okay. Now what happens? Stochastic gradients, it will come like this. Or it might come like this. This fella is, means it comes faster. It comes faster, but variance is high. Now your model output is y hat somewhere is standing here. Next cycle you go, it went here. You get confused. What is that? It is increasing. Again next it will come here. Next it will go. Means sometimes you get confused. Okay, it is going to reach somewhere. It is going to reach global minima. As it is coming nearer to the global minima, variance will, to some extent, the variance is going to reduce. Okay, so but the processing is fast. Processing is fast. Processing is fast. So okay, now I don't want too much fast. I don't want to tell anything to somebody. Some people born in 7th month. Quickly, everything they will do quickly. So they will not think. So that is like a stochastic gradient descent. So now, okay, I will come to some bargaining terms. I will come to. Okay, we will introduce a new concept. Any doubts till now? Any doubts till gradient descent and stochastic gradient descent? Shobha, Arti, Ignoel, Sunil, any doubts are there?
No, sir.
Okay. So you are getting what I am trying to say, right? So yeah, we want to reduce the loss. So now, what people came out with, one more term called as, what is this? Batch gradient descent. What is this? Batch gradient descent. Okay. So batch gradient descent. So instead of this, what you will do, you will take this in batches. So you have 10k data, not one at a time or not all 10k data together at a time, just like the previous optimizers. I will divide them into 10 batches. What happens here? 10k by 10 batches means for each batch 1k. Or you can divide them into 100. So 100 by 100, 100 into 100 is 10,000, right? So for each batch you have 100 samples we have. And we perform on these samples. Okay? how you are going to perform? How you are going to perform? And we are going to take the exponential moving average. We are going to take the exponential moving average. So now you tell me, what is moving average in mathematics? What is moving average? So I will tell you, this is very important concept. Not only in everywhere, in a whole deep learning process, or you go to any, you go general mathematics. Most of the time, everywhere we use this moving average for predicting the price of the stock. EMA, exponential moving average, always we take. In time series, for predicting the sales of the company for the next 10 months, 2 months, 3 months, we take exponential moving average. So, what is this? Moving averages. We have to give importance to the recent what is that? Recent data more than the older data. Or say, let us say, for understanding this, let us consider one example. Okay, the batch gradient is not only for batch, for next upcoming optimizer, ADA delta. Where is this? What are the optimizers? Batch gradient descent, ADA grad, ADA delta, ADAM. So anyhow, somewhere you should be knowing about it. So let us take an example. So let us say I have one equation, okay, EMA. I have, let us say I will write one equation. V is equal to, I will write initially V is 0, so I will write V1 is equal to 0.9 times of V0 plus 0.1 times of T1. Okay, this is plus, not T, plus this is, I will call this as yesterday's temperature. So, and this I will call as previous. So now let us say temp 1 or T1. Temp 1 is equal to 45 degrees. Temp 2 is equal to, I will say, 44 degrees. Temp 3 47, and so on up to temp n. Some n degree. Let us say temperature is 35 degrees. So for what is that? For my understanding. So if you want to consider, so this temperature of some system, okay, maybe of this room or somewhere else, is the governing equation for the temperature is V1 is equal to something. How it is? V1 is equal to, see, 0.9 times of V0. What is V0? Earlier nothing was there, 0. Suddenly you switched on some and it started with 45 degrees. Suddenly you keep something to heat. Nothing was there, it was 0 degree. You just from fridge and you want to keep it on the stove, switch on, the equation starts. So earlier it was 0. So how much you are going to give the weightage? 0.9. So now, and 0.1 into this is today's temperature. This is yesterday's temperature. 0.1 into temp 1. Now what is the temperature? 40. Yeah. Now what is the temperature? 45. Yesterday is how much? Yesterday it is 0. This term will become 0 plus 0.1 into 45. Okay. So something you are going to get. So similarly, so same way, if you continue, so what is V2? So 0.9 into V1 plus 0.1 into temp 2. Correct? Are you getting what I am saying? See, what is V3? 0.9 into earlier temperature was V2, 0.1 into today's temperature, so something like that. Means this V1, V2 again you can replace with equation. Correct or not? V1, V2. So in general what I can write? Vt, I can say this, I call it as beta constant. So V, what is this? Vt minus 1. This is 3, this is 2. This t means here t minus 1. Plus, this is 0.9, this is 0.1. What is this? 1 minus beta. Beta and 1 minus beta. This is Vt minus 1 into, this is temperature T and this is T. Right? So, what I am trying to say here is, I am talking about the exponential moving average. So here, how this is going to change, you look here. So this, how many values to consider? Now you are confused. I am also confused. Now let us say I just gave you one example. Means, did you understand anything from this? No. Means how much you have to give? What is the value of beta? How much you have to take? So how much previous points you need to consider? How much previous points you need to consider? In exponential moving average, you have 5 days exponential moving average, 10 days exponential moving average, 20-day exponential moving average, which is going to give you a better signal. How you want to predict for next, in next 2 minutes, how much my stock price, I want to earn profit, I want to make 1000 rupees now. Market will open at 950. I am an option trader. I have based on people always, people are making thousands of rupees, lakhs of rupees, crores of rupees. They on exponential moving average. So which exponential moving average is good? Some people are saying 20. Another friend is told, you put EMA, indicator is there in trading terminal. 20-day EMA you put, 9-day EMA you put, 5-day EMA you put, everything and 25, everything is going to cross. Just put on the buy signal. Yes, what happened? Hello guys?
Sir, the screen.
Screen not visible, huh?
Yes, sir.
Yes, 1 minute.
Yeah.
Okay, I am sharing this screen. Okay.
Didn't share there, sir.
1 minute.
Yeah.
You all of you stay online. I'll go out and I'll rejoin. Okay, don't go out because I am not getting the option to share this screen. I'll quickly join back. Okay, 1 minute. Okay. So you can see the screen, right? Sunil,
Yes, sir.
can you see the screen?
Yes, sir.
Okay. So now what
Yes,
I'm
sir.
yes.
I'm able to see the screen.
Okay. So now what I am trying to say is, how much exponential moving average needs to be considered. So your friend has confused you. So 5-day moving average, 10-day moving average, 15-day moving average, you don't know. Okay. So which will give me good result, which will predict the future price, or which is going to update my weights in a good way. So now let us, for example, that is what the question. This is $1 million question. How many times I need to, how many times, what is this? How many values, or instead of that, how many values I need to consider? What value means? 5-day moving average, 10-day moving average, 50. That 5, 10, 9, all those are values. So for finding the moving average, exponential moving average, previous how many values you need to consider? So that is my question. Means for finding the temperature, so here you have from 1 to several terms you have. So how much you have to consider? Here I am considering only temp 1, temp 2, temp 3. Okay, that's fine. So for now, let us say if beta, so beta is equal to 0.9. You have the term called beta. So beta is equal to 0.9. Okay. So similarly, if beta is equal to 0.5. So there are two cases here. Let us assume beta. Now just I will write simply. I am writing. I am just beta to the power of 20. So let us say I will get some value something like this. So beta cube. It's an arbitrary assumption. Don't think any no correlationship, nothing. I just written some random value. So what is this? So when beta is high, in general, thumb rule. People experimented this, they tested, practically, theoretically, it's working. Based on that, they are saying like this. This is not my invention. So try to see when beta is equal to 0.9. Beta is equal to means when beta value is high, when beta value is high, what is this? You will get 20 values. You will consider 20 values. When beta value is low, beta value is 0.5. Here beta value is 0.9. 0.9 is greater. 0.5 is lesser. When beta value is low, I will consider 3 to 4 values. This point 1, 2. See, you will end up with. So you will consider 3. Okay, that is why I have written beta cube. Here I have written beta 20. You have to consider. You will consider 20 values when it is too high. You will consider less values when it is beta value is less. Means so now you understood. Okay, how we are going to means 1 by 1 minus beta. There is one more terminology called 1 by 1 minus beta. See here, for example, 1 divided by 1 minus 0.9. How much? 1 minus 0.9 is how much? 0.1. 1 by 0.1 is how much?
10, sir, it's
10. So you will consider 10
yeah.
values. If beta is equal to 1. Similarly, 1 by 0.5 is how much? 1 by 1 by 2. How much values I will consider? 2. My statement is correct, right? What is my statement? Beta value is high. Beta values are high. Number of values will be low. Number of values will be low. If beta value is high, number of values to consider is here beta value I gave 0.9. What is the answer I got? 0.9. So beta value is equal to 0.9. Here you got 10 values. Number of values also, for high you will get 20 values. Correct na? 20 beta I consider 0.9. How much values you got? Means I have my assumption, but actually for 0.9 how many values you are getting? 10. So how much value you will get? 10 values. I assumed theoretically. Similarly, what is the beta value? 5. And beta value is 0.5. So what is the number of values you got? How much? 1 by 0.5. 1 by 1 minus beta 2. Means when beta value is low, number of values also. When beta value is high, number of means what is that beta? So what is that beta? Proportion 0.9 into V. That is today's temperature. That is what I gave you example. What is this? Previous beta means temperature, today's temperature into coefficient. Previous condition into coefficient. Beta is a coefficient. We multiply today's condition with some coefficient, that is 1 minus beta. and previous condition with some. So if the coefficient is too large, more values, beta value will be. If the beta value is higher, okay, if the beta value is higher, what happens? It will take time to converge to the global minima, obviously. So if the beta value is low, it will pass, means it will converge to global minima earlier, something like that. So you have to choose appropriate value of beta for when you are going to use this exponential moving average in your optimizers. Exponential moving is not an optimizer. This concept of exponential moving average is introduced in your deep learning model. So now I will come back here. Any doubts are there here in understanding exponential moving average? If there any doubts are there, you tell. You understood my concept? Somshekhar, Vaishnavi, Shobha, Aarti, Ignoel and Sunil. Yes, I will stop. I will explain again. No problem. I want you to understand.
No, sir.
No. Okay. So now, look at this. You have this equation, right? Okay. You have this equation. What is this? W volt. Sorry, always W nu is equal to W volt minus neta loss by volt. This is the general equation. So now what is volt? W t minus 1 is the Holder condition. Neta I will call this GT. I will replace this with the G, simply one term. Okay. So Wt is equal to, what is this new weight? I will call it as Wt. New weight is equal to, previous condition is t minus 1 neta into this differentiation. I will consider this as. So now this Wt minus 1, what is this? Wt minus 1, what I am going to do here, I will write it like this. Now you see, so instead of this, if I write like this, Vt is equal to gamma into V of t minus 1 I will write like this, not to confuse you. Wt is equal to Wt minus 1, there is this minus this n into gt, I will call it as V into t, I will call that as V into t. So W of t minus 1 minus V into t, I will call this as gamma t minus 1 or beta, whatever, gamma t minus 1. So gamma into V of t minus 1 plus n into neta into gt. So this is the equation for SGD. So now you see Wt. You observe the equation correctly. I will explain now. Observe the equation carefully. We will explain. So W nu, older weights, Wt minus 1, neta into gt, neta into gt. But this is not sufficient. I am adding one more extra term. What is this? Gamma into V t minus V is, that is what I told here, this term, this V. What is this? This whatever V I am discussing, this exponential moving average gets added into learning. This beta is different. Here it is gamma into V of t. This gamma is learning rate. Okay, this gamma into, so this term will give you the momentum. This term will give you the momentum. So previous values gets added based upon the percentage, how many values you have to consider. So point beta is 0.9, we consider 10 values. Beta is 0.5, we consider how many values? 2 values. Considering 2 values, you will find out V of t minus. That is the present state. V of t minus 1 is the present state, and that present state, you will add that to the equation. You will add this to the equation. So same thing only everywhere. This formula gets modified for each optimizers. Formula gets modified for each optimizers, and so what is this? This is the equation. You get it for the batch. The equation gets modified here for this gradient descent. So now you know this thing. Okay, what is this? Batch gradient descent, stochastic gradient descent, and gradient descent in general. So based on this, we are going to update the weights. So we will always replace the older weights with new weights. This older weights gets new weights in here in the model. Each and every node, this gets weights gets forward propagation once. Forward propagation weight is not going to be updated. Weight, it will check the output, how much gap is there, it will see. Based on that, back propagation happens. During the back propagation, first it got updated this one. So first, okay. So first it got updated here. So look at this. So, where is the figure? So it got updated. So back propagation. Next the weight, this will get updated. This two will be finished. This. Every weights, each means for this node means W23 got updated. Next this will update, means last come first updation. Last come first out, something like that. In that way, each means that is the weights that are nearer to the output node gets updated first. Then the immediate hidden layers, and at the end the weights that are nearer to the input layers. Means to consider to complete this in one epoch, almost all weights gets, means the one cycle. So in one epoch the weights gets updated. So in one epoch the weights get updated. So for this reason, for updation, why we are updating the weights? What is the need for updating the weights? So what is this equation? W nu. After updation of the weights, what you will do? Same, we will calculate. After updating the weights, again you will calculate y minus y hat. Y already you know. Y hat you are going to calculate. Same calculation, same how? x1 w1, x2 w2, x3 w3. What is this w1, w2, w3? This w new weights. So then your y hat will change. When it is going to change, the errors is expected to reduce. When the error is expected to reduce, it will try to reach global minimum. All optimizers will try to reach to global minima. The way how you are going to reach, that is what is designed. That is what different optimizers. You can try with any type of optimizer. There is nothing called. It depends. So if you want to see the difference, so look at the board. I will show you. So now, what we learned today: GD versus SGD versus batch gradient. So if you see, always try to see the images. You try to understand instead of reading the things. Look at this, how it is coming. Mini batch. Okay, I will told mini batch. It is, see, it is global minima is the point, center point. You have to reach there directly. Batch gradient descent, directly it is coming. Stochastic gradient descent. Single point, gradient descent, it is come. Stochastic variance. I told you there is a variance to come to the. So look at this. Smoother cost function as compared to SGD. Stochastic versus. So lot of difference is there. Look at this. Computes gradient using the whole training sample. Batch. Stochastic computes the single training. Stochastic single training not slow, computationally expensive, because here stochastic faster, it takes single, so it is a faster. Similarly, stochastic in nature, deterministic in nature, gives solution but not optimal, okay, because it is stochastic. Similarly, no random shuffling of points, but in stochastic data is going to be randomly shuffled because it is taking single points, not one by one, randomly it will be. Okay. So convergence is slow in batch gradient, stochastic reaches convergence with batch. So you people study the difference between. So look at this, batch gradient, stochastic gradient, and mini batch. Batch means gradient descent. Mini batch, I told you, as gradient descent, stochastic gradient descent, and batch gradient descent. But some people say instead of gradient descent, they say it as a batch gradient descent. Instead of batch gradient descent, they will say it's mini batch gradient descent. All are same. Okay. I think I am able to. Deep learning is complete dry theory based. Very difficult to people understand. Okay, something. Okay. So that is for today, and we have some more optimizers like ADA grad and ADA delta and ADA, some sort of advanced optimizers, okay, that we use in our deep learning. So first you should understand the theory. ADA grad, ADA delta, one line code only. Directly you will get the output. In 2 steps you will get output. Don't need of doing any data pre-processing, nothing like your machine learning. Deep learning models are advanced models. But you should understand what is happening behind the scene, otherwise it is not possible to grasp. Or you have somehow you have to tune the models. Should understand the things. Okay. So that's all for today, I think. We should stop here. If I can complete these two, but it will take 1 hour. If I start, I'll stop. Already 8:36. Okay. So 1 minute, I will stop the recording.